All right, so this is where we left off yesterday. And again, we're still finding the other trig value. So we're given one, and we want to find the rest. Now, again, just like with yesterday, one of the things I would start off by doing is drawing a right triangle. And that's a good place to start because it gives us a way to set it up to look at the angle in terms of the side lengths. And what they told us is we have secant of theta. And we're going to want to find sine, cosine, tangent, cosecant, and cotangent. Because luckily we don't have to find secant, they already gave it to us. But secant is the same as 1 over cosine, or the flip of cosine. So what that's telling us is that cosine is actually 7 over 17. And now that we have that, we know that the adjacent side is 7, and the hypotenuse is 17. It gives us a place to start. And now that we have that, we can use Pythagorean theorem. A squared plus b squared equals c squared to find the missing side. So we'll say 7 squared plus b squared equals 17 squared. Really, I can subtract 7 squared from both sides, telling us that b squared is equal to 17 squared minus 7 squared. And lastly, take the square root of both sides, telling us b is, well, square root of 17 squared minus 7 squared is 4 squared of 15. Because, I mean, I could have taken that individually, said 17 squared is 289, 7 squared is 49, so 289 minus 49 is 240, and the square root of 240 is still not there, or I just plug it in as a whole piece. Now our sine value is opposite over the hypotenuse. Well, the opposite side is 4 square root of 15, and the hypotenuse is 17. Tangent of theta is opposite over adjacent. So 4 square root of 15 over 7. Cosecant is 1 over sine, or the flip of sine. So 17 over 4 square root of 15. But we will need to simplify that. 17 over 4 second square root of 15 is 17 square root of 15 over 60. And cotangent is the flip of tangent, which is 7 over 4 square root of 15, which should end up being 7 square root of 15 over 60 probably. But we can make sure. And we get this here. And those are our 5 answers. Questions on any of this here? Question on anything we've done so far? We ready for the next one? Because those are about the same, because once we set the triangle up and get it set up, the rest of it kind of follows. We're just plugging in the given information. Now we do have something called complementary angles. Sine of 90 minus theta is equal to cosine of theta. And cosine of 90 minus theta is the same as sine of theta. We go back and forth. Tangent of 90 minus theta is the same as cotangent. Cotangent of 90 minus theta is the same as tangent. Secant of 90 minus theta is equal to cosecant, and cosecant, same thing. So if we know the angle of 1, we know what its complement is. So sine of 30 degrees, tangent of 30 degrees. Well, sine of 30 degrees is I don't want to have, I think it's mode degrees. Sine of 30 degrees is 1/2. Tangent of 30 degrees is square root of 3 over 3. And these we just calculated. Now, most of these here we could calculate with a calculator and go from there. But if we wanted to do these, well, cosecant. I'm going to just jump to B. Here, cotangent of 60. Well, this is the same as saying tangent of 90 minus 60, which is tangent of, which is our square root 3 over. So cotangent of 60 is the same as tangent of 30. We get the same value. Which means cosine, or cosecant of 30 is the same as, I see what I'm trying to do. Secant of 90 minus 30, which is our secant of 60 degrees. Cosine of 30 is the same as sine of 90 minus 30, or sine of 60. And our cotangent of 30 is the same as tangent of 90 minus 30, or tangent of 60. So we can work from one to the other. Especially if we're given one of those values, we could find the rest. Does that make sense? Now, evaluate using a calculator. Well, we can evaluate these in different ways. So here, 5 degrees, 40 minutes, 12 seconds. Secant now, it might be tempting to say second sine and do this here, but that's not the same. Because that's sine inverse. It's the inverse function, not our reciprocal function. So there's a little bit difference with that there. Because if we said sine of, it's in radians, so pi divided by 4, we get this here, which is square root 2 over 2. Well, let's actually make something a little bit better. Let's say it's 1/2, 30 degrees, pi over 6, 1/2. So if we did instead to the -1, we do get our cosecant. So this one does work. The graphing calculator will do this mainly because it's converting it to a decimal, not a fraction. Now, secant of 5 degrees, 40 minutes, 12 seconds. So secant is our reciprocal of cosine. So if I wanted to plug this in, we're really going to plug this in one of two ways. We can say 1 over cosine of 5 degrees, 40 minutes, 12 seconds. or we can say cosine of 5 degrees, 40 minutes, 12 seconds to the negative 1. We'll see it in both forms. So 5 degrees. So we can go 5-second angle degrees. 40-second angle minutes. 12-second angle, well, second catalog, seconds. And then we put it to the negative 1. I got those extra 2. Enter. 1.2227 or 1.2228 is the answer. Now we could have done alpha y equals enter 1 over cosine 5 degrees 40 minutes 12 seconds, and we see that we do get the exact same thing. Questions on this here? The only other way that we could have done this, instead of typing this whole thing in, is I could have started off with saying that this is 5.67 and saying cosine of 5.67 reciprocal, same thing. But there is a problem with this. There we go. What was the error was I had it in what? Radians instead of degrees. So it should be 1.005. Is our actual value for this here. And now if I come back up here, hit enter, we do get the correct value. So again, on all of this here, you didn't have to worry about this as much in the geometry class because everything was in degrees. Here we do have to be careful. Are we talking about radians or degrees? One of the biggest giveaways that were with degrees is the degree symbol. If it's in terms of pi, pi is a part of our angle, it's in radians. So that's one of the bigger giveaways. Cosecant. Well, this is our sine. 34 degrees, 30 minutes, 36 seconds. And we could plug it into the negative 1. Degrees. 30, 36. .56655, or we can say 0.5666. That's it. Because we can convert the angle from degrees, minutes, seconds to just degrees, then plug it in, or we can plug it into the graphing calculator as a whole. Any one of these ways works. Questions on any of this here? Fundamental reciprocal function. Sine is 1 over cosecant. Cosine is 1 over secant. Tangent's 1 over cotangent. And the reverse is true. Cosecant's 1 over sine. Secant's 1 over cosine. Cotangent's 1 over tangent. Quotient identities. Tangent sine over cosine and cotangent's cosine over sine. And we went over the fact that tangent is sine over cosine. I was able to show y'all how that worked and that it is true. One of the bigger ones and the ones that are very helpful are these three here. Sine squared plus cosine squared is 1. 1 plus tangent squared is secant, and 1 plus cotangent squared is cosecant. In a lot of stuff we do, these are some of the most important ones that you'll have, especially when solving. These come in very handy and are very useful for helping us out. Let theta be an acute angle such that sine of theta equals 0.6. Find the values of cosine and tangent using the trigonometric identities. So, the main ones that we use, especially when going with sine and cosine, if they're the same angle, we're going back to these here. So the first thing we need to solve for is cosine. Well, sine squared of theta plus cosine squared of theta is equal to 1. Well, knowing what sine of this angle is 0.6, because that was given to us in the problem. So we plug it in. We plug it in for sine. And now we're just going to solve for cosine. Well, 0.6 squared should be 3.6. It's 0.36. So we have 0.36 plus cosine squared of theta is equal to 1. Now at this point here, we can get cosine by itself by subtracting 0.36 from both sides, which will tell us that cosine squared of theta is equal to 0.64. And lastly, we're going to square root both sides, telling us that cosine of theta is equal to 0.8. Let theta be an acute angle such that this is true. Well, this is going back more to our chart. And when I say chart, I mean unit circle. Because we're told, I'm going to draw the coordinate plane out, that sine is positive. Well, sine is positive in the first and second quadrant, yes? Cosine is positive in the first and negative in the second. And because we're not talking about a reference angle, there's no way we're going to be talking about the second quadrant because that would have to be an obtuse angle. So for this here, we're only going to look at the positive case because truly it would be plus or minus 0.8. But for cosine to be negative, the angle has to be obtuse, so it has to be positive. Does that make sense? And that plus or minus case does come into play because it could be that based off our setup that the positive case doesn't work but the negative does, or vice versa. Questions on this so far? Now there was a second part to it. They also wanted us to find the value of tangent. Tangent's what? Sine over cosine. Well, we know sine's value is 0.6. Cosine is 0.8. 0.6 over 0.8 is 0.75 or 3/4. So tangent of theta is 3/4 or 0.75. Questions on how we solve these? Let theta be an acute angle such that cosine of theta is 0.96. Okay. I still have not fixed this. Because that should be sine, not cosine, because cosine would make absolutely no sense. Because it would just mean it's 0.96, because we already have it. So this time the first thing we want to find is sine of theta. So we're going to use the same formula. So I have sine squared of theta plus 0.96 squared equals 1. Will the value of 0.96 squared be greater than 1? Yeah. I mean, would it? Well, think about it, because these two values added together equal 1, yes? So if that one's greater than 1, it means sine squared would have to be less than -1. Yep. So let's see. 0.96 squared is in some it makes sense, but well, it actually works out it won't, because we have 2 decimal places, yes? Well, if I square it, multiply by itself, so we'd have to move the decimal over, not 2, but 4, because we have 2 of them. So it ends up being not working out, unfortunately. And I've already lost the number. 9216. Now at this point here, we're going to subtract our value over, telling us that sine squared of theta is equal to 0.0784. .0784, and lastly we would square root both sides. Second square root second answer 0.28. And that's it. Questions on this here? Now we need to find tangent. Well, again, tangent is just sine over cosine. Well, sine was told to us, or we found, is 0.28. Cosine is 0.96. 0.28 over 0.96 is that there, or 7/24. But that's it there. And again, it's not that we're doing a whole lot of specific calculations or different things. We're just going back to the definitions and plugging in what we know, solving for the rest. Questions on this here? given that tangent equals 1/3, find the values of cotangent and secant. Well, cotangent is what? 1 over tangent, yes? So we're just taking tangent and, so cotangent would be 3 over 1, which is 3. Now, secant squared is equal to tangent squared plus 1. So to find secant, so secant squared of theta is equal to tangent squared of theta plus 1. Now we know tangent is, for our given angle, is 1/3, so we can plug it in. Now on this side we have 1/3 squared plus 1. Well, we can actually type that in a calculator. 1/3 squared plus 1 is 10 over 9. And lastly, we will square root both sides. Now secant squared is just going to be secant. Now square root of 10 over 9 give us square root of 10 over 3. And we get this here. Now normally we would definitely say the plus or minus. I want to verify that, because it didn't tell us anything about the angle specifically itself, especially if it is acute or not. Yeah, so just extract the positive square root and simplify. Because I didn't include it here, but it does say let theta be an acute angle, so we just want the positive case. Questions on this here? But hopefully you notice really all we're doing with any of this here is just simplifying. Now, square root of 10/9, and you can see here just plugging in, that doesn't work well. But if we want to plug it in, we can say secant square root of 10 over secant square root of 9. And it'll reduce it for us. If the denominator didn't, because square root of 9 is just 3, it simplifies nicely. If it didn't, it'll do it for us. Because I'm going to change the 9 to 12. It'll reduce it, put it in simplest form for us. But for us to be able to do that, we do have to split it into 2 separate radicals. Questions on any of this here? Given that tangent's 2, find the value of cotangent and secant. I don't feel like we need to see another example of this. I think y'all feel pretty comfortable with this. Okay. Excuse me. Now, this is the last part of this section that we're looking at, because we have 2 of them. And a student last year gave this the turn of phrase as cheating, because I think you remember her saying that. Not so much cheating, but feels like we're cheating with mathematics, because most of it, I kind of agree with what she's saying, and it's not cheating in the sense that we think of cheating and getting the answer. It feels like that because we're going to be taking these here and messing with them to get what we want. And what we want to do is we want to prove that sine minus cosine times sine plus cosine is equal to 1 minus 2 cosine squared. Now, whenever we prove stuff or prove something's true, we want to show that these two sides are equal, yes? And one thing we cannot do is move stuff across that equal sign, okay? Because in this here, I cannot subtract this one from both sides or add the 2 cosine squared to both sides. It's just not possible. Now, the reason for that is we're wanting to show that the left side is equal to the right side, yes? But all the properties of being able to subtract the same something from both sides or add something to both sides, we can do that under the assumption that they are equal, yes? Well, do we know at this point that they are? Well, no, we're trying to prove that they're equal, yes? I can't do stuff that's under the assumption that they are equal while trying to prove that they are. That's pretty much saying I'm accusing you of cheating, and to prove it, I'm going to use the fact that you are cheating. But no, I have to prove it before I can state it, and I can't use it's backwards logic. Yes? So it doesn't work. It's almost like I know that the two people are dating because they're dating. Well, how'd you know they're dating? Because they were. Well, one doesn't imply the other. So what we do, and when we treat this, is we treat it like a brick wall between the two. And if I can make the left side look like the right, or the right side look like the left, then we've proven that they're true. Or what we can do is get both sides, the left and right side, I can work both of them down to be the same spot. Because as long as I get them to be the same, we've proven that they are equal. Now over here, the first thing we're going to do is distribute this here. Sine times sine is a theta. Sine times cosine is plus sine of theta cosine of theta. Cosine of theta times sine of theta is negative sine of theta cosine of theta. Move that over. Actually, move it over completely because I just ran out of room. And negative cosine times cosine is negative of theta. Now the middle term is gone. Sine times cosine minus sine times cosine, that's the same thing, so they're out. So what we're left with is sine squared minus cosine squared of theta, yes? And this part, the next part is really where the student last year said it felt like cheating. It's like, well, I need this in completely in terms of cosine, yes? Well, these three here are the only ones that have a square. Well, I'm going to take this formula and get it in terms of sine. And to do that, I'm going to subtract cosine squared of theta from both sides. These cancel out, telling me that sine squared of theta is equal to 1 minus cosine squared of theta. So, with that in mind and coming back over here, I can now replace sine squared with 1 minus cosine squared of theta, minus cosine squared of theta, which gives us 1 minus 2 cosine squared of theta. Is that good? Now it's starting to see. Because, I mean, up to this point, in most every single math class that you've had so far, it's pretty much been, this is the theorem, this is how we use it, that's it. You plug the values in, you get your answer. That is it. We don't really mess with the theorem. We don't do a whole lot with them. Here, it's like, well, I'm going to erase all that. Well, this statement's true, but we also have that sine squared of theta is equal to 1 minus cosine squared of theta. Or cosine squared of theta is equal to 1 minus sine squared of theta. On the other side, we also have that tangent squared of theta is equal to secant squared of theta minus 1, or that cotangent squared of theta is equal to cosecant squared of theta minus 1. I can manipulate these so that I get something that I want to actually work with or helpful to use. Now we have this last one here. Sine squared times 1 plus cotangent squared equals 1. Now there's different ways we can go at this. One is I can distribute sine squared. Well, sine squared times 1 is just sine squared of theta. Sine squared times cosine squared is plus sine squared of theta, not cosine, cotangent squared of theta. So I have sine times cotangent, 1 plus cotangent squared. And if we multiply through, we get this. So sine squared plus sine squared times cotangent squared. Questions on any of this so far? Now, to simplify down, well, I can rewrite cotangent in terms of sine and cosine, because cotangent is cosine over sine. So cotangent squared is cosine squared over sine squared. And because we have this, the sine squared and sine squared will simplify to 1, leaving us with sine squared of theta plus cosine squared of theta. And by one of our Pythagorean identities, sine squared plus cosine squared is 1. So this whole side is 1. Questions on this here? Erase all that. If we look down here, 1 plus cotangent squared is cosecant squared. So I could have done that. I could have said that sine squared of theta, this whole thing is cosecant squared of theta. Well, cosecant squared of theta, or cosecant is 1 over sine. So really, I can rewrite cosecant as 1 over sine squared of theta, and those multiply together to give me 1. So there's more than one way to get or prove that they're true. But it's just figuring out which is the best way to go about it. But that is the end of 1.3.